In this tutorial, we will walk you through the steps needed to complete a basic fluid simulation using the document called Discovery Ducts. You can see in the structure tree that there are 3 components making up this assembly. Click the checkbox on component number 2 and you'll see a small probe in the assembly, for which we will look at later. Click the checkbox to show the main duct again. To start the fluid simulation, let's click on the Create Solution button, then Fluid Behavior. Be sure to select the Create Fluid Volume option, then Internal Flow, and finally Create. The next step is to define boundary conditions. Click on the inlet, then outlets as desired. Before clicking, hold the Control key to change an inlet to an outlet. Immediately you'll see a fluid simulation begins once all 3 openings have been selected. To begin editing parameters, you can change things like fluid velocity on the left-hand side, either by typing in a value or dragging the slider up and down, and instantly you will see the simulation update. Next, let's explore the different types of views in the Solutions panel control box. The current display is set to velocity, and we will leave that as is. Change your view from surface to composite, and you'll see a smoke-like view of semi-transparent colors showing velocity profiles. The center slider bar option will let you focus around a certain velocity, and the bandwidth controls the expanse of what is shown. Next, turn the Streamline button on and the composite view off, and drag the blue arrow to the right. Also in this interactive result, you can drag a small handle to modify the opening from which the streamlines emit. Notice that there are less streamlines at the top of the duct. Turn the streamlines off and the composite view back on. Before we add some calculated values on the screen, let's add a point at which we want to take a measurement. Going to the Sketch toolbox, click on the Point button, then click the end face of the duct farthest away from the inlet. Then click somewhere near the center of that duct. You can hit D on your keyboard or the Return to 3D Mode button. To create calculated values, click the bottom middle button on the Solutions panel. Click More, then Max Velocity. Click Select, then the point we created earlier. Notice after a few moments the velocity value starts to settle down as time goes on and a steady state solution is reached. Now change the velocity to a number dramatically different and watch the chart instantly update. Let's start to make some geometry modifications. Using your middle mouse button, place the perspective of the model in a view like this. So you can drag your mouse from right to left and select the 5 faces I have shown. Under the Design tab, select the Move tool. Next, drag the blue arrow away such that the ducts are further apart from each other. Instantly, you will see the simulation has updated with the geometry change you just made. A final observation we will make is to go into a cross-section mode. Under the Design tab at the top, select the Cross-Section Mode button, or just select X on your keyboard. Click anywhere on the screen to place the cross-section. You can use the Move Grid button to adjust the location of your cross-section at any time. Next, select the Pull tool under the Design tab and drag the end face of the gray probe. Again, you will see the velocity update instantly. And finally, drag the diameter to a new value that's greater than it previously was, and as before, the simulation will update in real time. Thank you for watching, and for more information or helpful tutorials like this, please visit ansys.com/discovery.